All right, in this problem, it's talking about on the way to the moon, Apollo astronauts reach a point where the moon pull is stronger than that of Earth. So this is like that other problem where you take two masses. So here's the Earth, and then over here is the moon, right? I probably drew that too small, whatever. Here's the Earth and the moon, and there's going to come a point somewhere where the spacecraft, right? So here's the spacecraft, is at a point where the net force is going to be zero. Okay, so this is really similar to that other homework problem where you had two masses and you're trying to find the point where it's zero, except it's a little bit easier. Okay, so we know the distance between the Earth and the moon, and I know the mass of the Earth and I know the mass of the moon, right? So I'm trying to find that distance. So let's think of what we know at that point. So at the point here where it's the same, I know that the force from the Earth is going to equal the force from the moon, right? Sorry, that should look like an M. So that means that G times the mass of the Earth times the mass of the spacecraft over R squared. I'm trying to find R from the Earth, right? This is going to be R. That's going to equal G times the mass of the moon times the mass of the spacecraft over R squared, right? And so again, just like the last one, look at this. The mass of the spacecraft cancels out, right? Because it's the same in both cases. G goes away, and it's basically mass of the Earth over R squared equals the mass of the moon over R squared, right? So I can rewrite that if I cross multiply and square root, right? So I'm going to cross multiply. That's mass of the Earth R squared equals mass of the moon R squared. And then, radius, I'm sorry, these R's, this is the radius from the Earth, and the other one is R from the moon. So I should technically, this is Rm. So mass of the Earth times the radius from the moon squared, mass of the moon, radius from the Earth. It's not really radius, it's separation, right? And so then if I rearrange these, I can say that the mass of the moon over the mass of the Earth, the square root of that, equals the separation from the moon over the separation from the Earth. Right, so I moved that over and I got rid of the squares on the two R's by taking the square root of both sides, right? And that gives me this. So here's one thing I know. And then the other thing I know is that the total distance between the Earth and the moon, I'm going to call that big R, right? That total distance is equal to the distance between the Earth and the thing plus the distance between the moon and the spacecraft. So R equals R. R equals the radius from the Earth plus the radius from the moon, right? So I'm going to say big R equals R Earth plus R moon. Okay, so I can take these two things and I can plug this into here, right? I'm going to take this and I'm going to plug it in down here. I'm going to solve this for Rm, and I'm going to get in terms of Re, right? So if I take that and plug in here, this says R equals Re plus Re times root moon mass over Earth mass square root, right? So I have this, so let's try to simplify, right? So, okay, so that's equal to R Earth times 1 plus root mass of the moon mass of the Earth, right? Because then I could distribute that Re in and I could get back to here, right? So I just pulled that out. Oh, look, I'm done, right? So if I want to solve for the distance from the Earth, I can just divide this over. So the distance from the Earth, Re, which is what I want. I'm trying to find that distance. The distance from the Earth is going to be big R, which is the total distance between the Earth and the moon. Big R divided by 1 plus mass of the moon over mass of the Earth, the square root of that, right? So if you do that piece by piece, do that first, square root, 1 plus that, R over that. If I do that, that'll give me the distance between them. So not too bad, just doing a little algebra, taking two things that we know and plugging them into each other, kind of like all the harder problems, and solving for the distance between the Earth and the spacecraft.